Okay, so nitrous acid plays a particular role in these reactions with amines. So this is something we're going to have to go over. And nitrous acid is actually HNO2, not nitric acid, HNO3. It's actually the weaker of the two acids, but we'll see why it's important here in a second. What happens is that nitrous acid in the presence of some other strong acid. Well, we actually saw a similar type of rearrangement when we were talking about HNO3 in nitration reactions. Remember, we added sulfuric acid in order to create this guy here, which was a very strong electrophile that was attacked by benzene. Something very similar is going to happen with the nitrous acid. In the presence of strong acid, it's going to form a potent electrophile, okay? In this case, it's this nitrosonium ion, okay? So let's see exactly how that happens. So again, we have our strong acid that's going to be grabbed by that oxygen, right? So that we have a proton transfer. The acid is doing its job. It's donating a proton. So now we have our nitrous acid. This is again going to accept another proton from this strong acid. And now we have a good leaving group here. And so that's exactly what happens. This pops off as a good leaving group, leaving us with this nitrosonium ion. As you can imagine, the nitrosonium ion is not particularly stable. You're not isolating a mole of nitrosonium ion, but it forms in large enough quantities or frequently enough that it can then react further. And it is a potent electrophile at this particular nitrogen, right? This particular resonance structure, you can see that this nitrogen doesn't even have a full octet. So it is an incredibly strong electrophile. It really wants to accept a pair of electrons. This is the more stable of the two resonance contributors because everybody has a full octet, but that's also why it's not an electrophile, right? The oxygen here, even though it has a positive charge, it has a full octet, so it's not going to go accepting electrons. So although this is the more stable resonance contributor, this is the active one that we're going to see in further reactions, okay? So again, similar to what we saw in our nitration of benzene reactions, nitrous acid will react with a strong acid catalyst to form this potent electrophile, in this case, the nitrosonium ion. And again, we talked about these two resonance contributors. This one's the more stable, but this is the active one because, again, the nitrogen, not only does it have a positive charge, but it also doesn't have a complete octet, right? So it really wants to accept a pair of electrons. Okay, so we're going to see that amines react with this nitrosonium ion. That's the bottom line, okay? Secondary amines will react to produce an N-nitrosamine, nitrosamine, okay? That's this guy here, this big weird looking group. Okay, that's what secondary amines will react to form. So let's see what that happens. So first of all, we know that the nitrous acid will react in strong acid catalyst in order to form this particular nitrosonium ion. Again, this is a potent electrophile, so our amine is going to act as a nucleophile and attack that. And now you're pretty much there once it does that attacking in terms of getting to your product. The only thing that needs to happen is a proton transfer in order to get rid of that hydrogen. Okay, so then you're kind of stuck at this position, this nitrosamine. Nitrosamines are apparently terrible for you. They're found to be potent carcinogens, so in all the bad stuff. If you have a primary amine, and this is by far the more important reaction out of the two, you actually get what's called a diazonium salt. So look at this guy here. Okay, so this is also reacting with this nitrosonium ion to form this diazonium salt. Why is this such a big deal? Well, what happens when it accepts this electron from this bond? It will leave as N2. And remember, we discussed how nitrogen gas was just a great leaving group. So that's sort of going to be the deal here is this nitrosonium salt, or I'm sorry, this diazonium salt is going to be a great leaving group. So that's what we're going to see actually in the next lecture. For now, let's focus on how this reaction occurs. The first half is the same of what we just saw, okay? So the first half, we have the formation of the nitrosonium ion, right? We went over that first. Now we have the nitrosonium ion is what? A nucleophile or electrophile? It's a good electrophile, so it's going to accept that pair of electrons. Now I get to this step here, where again, I have that weird looking functional group. I got to deprotonate in order to sort of finish that step off, right? So the first step I have is the formation of that N-nitrous amine. There's an A in there. Whatever, that weird looking functional group there. But now it's going to go one step further, okay? So now we have our acid catalyst that's going to protonate that oxygen, okay? That's going to then, this pair of electrons, we're basically going to be able to get rid of the hydrogen that's on that nitrogen. That pair of electrons comes down and forms a double bond and kicks that up, right? So now again, I have this neutrally charged intermediate. But because we're in acidic conditions, that oxygen is again going to accept a proton. So now I have this here. And what does this look like to you guys? Hopefully a pretty good leaving group, which is exactly what happens. That pair of electrons on the nitrogen comes down and kicks that off. And so what we're left with is a nitrogen with a positive charge. Notice it still has a complete octet. It just has 4 bonds. And again, this is going to be this diazonium ion, which is going to be a good leaving group. Okay, so the sort of review of this chapter was just what happens with the nitrous acid. So you should be able to go from nitrous acid to this nitrosonium ion. Forgot what it was called. Nitrosonium ion. Right, that's the first step of all these reactions. If you have a primary amine, that will react with the nitrosonium ion to form the diazonium salt. This is sort of by far the more important of these two reactions because we're going to see that that plays the role of a leaving group. If you have a secondary amine, you're actually going to form this N-nitrosamine, which is this weird looking functional group here, which is again apparently just terrible for you.